Okay, students, here we have a problem about finding the probability of grouping two friends. A teacher randomly divides a class of 10 students into two groups, Group A with 4 students and Group B with 6 students. Two friends, Alice and Bob, are part of the class. The first question is, what is the probability that Alice and Bob are assigned to Group A? And the second one is the probability that Alice and Bob are assigned to Group B, and the third one is the probability that Alice and Bob are assigned to the same group. Okay, let's go to the solution now. The first one, the probability that Alice and Bob are assigned to Group A. Okay, so we want to find probability of uh, Alice, Bob to be in Group A. So in order to find this probability, first we have to find the total number of ways we can assign four students to Group A. So we need to know in how many ways can we create this Group A from the total number of 10 students. So we have the total number of students is NS is 10. So we have to know the number of ways we can create Group A from the total number of 10 students. In how many ways can we choose 4 people from the 10 students in order to create Group A? In how many ways can we create Group A? In how many ways can we choose 4 students from this 10 total number of students? So the number of ways we can assign 4 students to Group A is this one. We need to choose 4 from the total number of 10 students. This is a combination problem. It's going to be 10 choose 4 equals to, in order to remind you of the general formula for a combination, I will write it here. N combination R is going to be n factorial over R factorial into n minus R factorial. This is the formula for a combination. For unordered, we call it unordered sampling. In how many ways can we choose R from the total number from the n? In how many ways can we choose R from n? So it's going to be 10 choose 4, 10 factorial over 4 factorial into 10 minus 4 factorial. If we do this, if we do this in a calculator, it's going to be 10 factorial 4. It's going to be, you will get 210. So this are 210. It's number of ways we can assign for students to Group A. But the question is asking for the probability that Alice and Bob are to be present in this Group A. So we have found the number of ways. In how many ways can we assign 4 students to this group? So we have 210 ways or combinations in order to form this group. But we are asked to find the probability that Alice and Bob, both of them, are to be present in this group. So in order to find the ways or the number of combinations where Alice and Bob are going to be present in some of these 210 total combinations in order to form the group A, we'll proceed with this assumption. For Alice and Bob to be assigned to group A, let's assume we know that group A, it has 4 spots. its size is 4 students. So for Alice and Bob to be present in this group A, we'll assume they are present in that group. So we have the first spot. In the first spot we have Alice, and in the second spot we have Bob. So we have flexibility with the two remaining spots in group A. So for these two remaining spots, we'll find the number of ways we can fill these two spots from the remaining 8 number of students. Here we have to be careful. We should not choose 2 from 10 because we are assuming Alice and Bob are going to be in the group. So the total number of students is going to be decreased by 2. So we have 8 here as the remaining total number of students because we are assuming Alice and Bob are in the group already. So for these two spots, we need to find the number of ways we can fill these two spots from the remaining 8 number of students total from the remaining. So we need to find this one. So this is going to be 8 choose 2 equals to 8 factorial over 2 factorial into 8 minus 2 factorial. It's going to be, I am using a calculator here, 8 combination 2, you will get 28. So we have 28 number of ways where Alice and Bob are in group A together. Therefore, the probability we want is now probability of Alice and Bob to be in group A. We have number of ways Alice and Bob are present in group A over the total number of ways we can form group A. For the total number of combinations we can create group A. We can assign first element to A. Therefore, the answer is going to be the number of ways Alice and Bob are present in group A. We found it here 28. And the number of ways you can assign first elements to group A, or the number of ways we can create group A from the total number of 10 students. We found it here. It is 210. Therefore, this probability, I will check in my calculator if you can simplify it. It's going to be 2 over 15. So this is the answer for the first question. Then the second question was asking for the probability that Alice and Bob are assigned to group B. You follow the same procedure. The size of B size is 6, and we have total number of students 10. Then we are asked to find the probability of Alice and Bob to be in group B. First, we need to find the number of ways we can create group B from the total number of 10 students, or the number of ways we can assign 6 students to group B. It is going to be 10 choose 6, 10 factorial over 6 factorial into 10 minus 6 factorial. Using a calculator, we will get 10 combination 6, 210. So we are getting the same number of ways to create group A. I think this should be intuitive. I think this one, because as soon as we are creating group A, group B will be automatically created. And next we need to find the number of ways where Alice and Bob are going to be in group B. So here we will follow the same reasoning as for the first question. We have group B and it has 6 spots. This is group B. We said its size is 6. We have 6 students in group B. So we have 6 spots. 1, 2, 3, 4, 5, 6. The first 2 spots, they are already assigned to Alice and Bob because we are assuming they are in group B. So in the first spot is taken by Alice, and the second one is taken by Bob. And we have here Alice. So we have flexibility with the 4 remaining spots. These are flexible. So we need to find the number of ways we can fill these 4 spots. In how many ways we can fill these spots? So it's going to be automatically the number of ways Alice and Bob are going to be present in group B. So here we have to be careful. We need to choose 4 students in order to fill these 4 spots here. From what? From 8. From the 8 remaining students, because we are assuming Alice and Bob are already assigned to group B. So we have flexibility only with 8 students remaining, and from these 8 students we need to know the number of ways we can choose 4 students from the remaining 8 students. So the formula is going to be 8 choose 4 students. 8 factorial over 4 factorial into 8 minus 4 factorial. Using a calculator, we'll get 8 combination 4, we'll get 70. So we have 7 ways we can create group B where Alice and Bob are available both in that group. And this 210, it is the number of ways we can create group B, whether Alice and Bob are present or not present. These are the number of ways we can create group B. While this 70, it is the number of ways we can create group B, but Alice and Bob must be present in that group. So the probability we are asked for the second question, we can find it now. Probability of Alice and Bob to be in group B is equal to the number of ways where we can form group B where Alice and Bob are available, and we found it to be 70 over the total number of ways we can create group B from the 10 number of students, and you found it here 210. And this is going to be, if you simplify it using calculator, 70 divided by 210, it's going to be 1 over 3. This one third. Okay, so we are done with the second question. We are remaining with the third one, and the third one, it asks for the probability that Alice and Bob are assigned to the same group. So we can rephrase this question. It is asking for the probability that Alice and Bob are either in group A or in group B. In the first one, we found the probability that Alice uh, and Bob are in group A, and we found it to be 2 over 15. And in the second part, in the second question, we found the probability of Alice and Bob to be in group B, and we found it 1 over 3. And the third one is asking the probability that Alice and Bob are assigned to the same group. So, in other words, the question is asking for the probability of Alice and Bob to be either in group A or in group B. So we are ensuring both of them are assigned to the same. They can be in group A or they can be in group B. So we have to possibilities, and they are exclusive events. So the probability that both of them are to be in the same group is going to be the addition of probability of Alice and Bob in A and the probability of Alice and Bob in B. So the required probability is probability of Alice and Bob in same group is probability of Alice and Bob in group A plus probability of Alice and Bob in group B. And okay, let's add the numbers 2 over 15 plus 1 over 3. Okay, let's do it. 15. Okay, 15 by 15, we have 2, we have 5 here, so it's going to be 7 over 15. So this is the required probability for the certification. So we are